Mole Concept, Part 1. We will realize that depicting a chemical change on the basis of the number of particles, atoms, molecules or ions is of greater significance than doing so on the basis of their masses. H2 gas, 2 atoms, plus Cl2 gas, 2 atoms, gives twice HCl gas, 2 molecules. Ag plus aqueous, 1 ion, plus Cl minus aqueous, 1 ions, gives Ag plus Cl minus, solid or AgCl, 1 formula unit. Atomic and molecular masses are measured with respect to C12, so let us try to see if the number of atoms in a gram atom of an element is related in some way to that in 12 grams of 12C. Suppose the relative atomic mass of an element A is X, hence 1 gram atom of A weigh X grams. Let the number of atoms in 12 grams of carbon 12 be N, and that in 1 gram atom of A be N dash. Therefore, N into mass of 1 atom of carbon 12 is equal to 12 grams, and N into mass of 1 atom of A is equal to X grams. So, N dash into mass of 1 atom of A divided by N into mass of 1 atom of C12 is equal to X gram by 12 grams. N dash by 12 into N into mass of 1 atom of A divided by 1 by 12 into mass of 1 atom of C12 is equal to X by 12. N dash by 12 into N into relative atomic mass of A is equal to X by 12. N dash by 12 into N into X is equal to X by 12. So N dash is equal to N. Thus, 1 gram atom of an element has the same number of atoms as that in 12 grams of carbon 12. We can easily prove this to be true for the number of molecules in 1 gram molecule and that of ions in the 1 gram ion of any kind. An assemblage of this number of particles is known as a mole. Mole when used as a unit, which may be defined as follows.